Hi, Tom Dean here with Flynn,
Hey,
and
how goes?
welcome to the Service Mesh Academy. Today we are going to talk about things that are new. We just recently released Linkerd 2.16. There's some good stuff in there, and I got to say that this has been the most glorious release. I do a lot of work on the front side of sales and the back side supporting customers, and we literally had one small bug with this, and it's just been total glory to go to. So,
It's
with
been really nice seeing the developer staff not being massively stressed after a .0. It's been really cool.
Yeah, not even taking into account it's a .0, and that's just amazing that we had like a very smooth delivery with this one. And there's some
Yeah.
great new stuff in there that Flynn's going to go ahead and cover. So I will hand it over to Flynn.
All right. Did that work? Hey, that
Yeah.
worked. Yeah, so we're here to talk about this was set up as the top 5 things you need to know about Linkerd 2.16, which wouldn't fit on the slide. So, yeah, top 5 things. Off we go. There is, of course, the Linkerd Up and Running book. You should go check that out since Buoyant has graciously decided to sponsor that and give it away, which is pretty awesome, both for me as one of the authors and for you as people who can read it. So thanks to Buoyant for that. Okay, what's on the agenda? We're going to do, I say, a quick discussion of the features. It's a fairly quick discussion. Some of the features need a little bit more discussion than we might have thought in the beginning here, and then we're going to get into a demo of some of these things. The source is newly up in the 2.16 features directory of the Service Mesh Academy repo. I will be running this on Enterprise 2.16.0, the aforementioned most incredibly stable release or smooth release that we've had in quite some time, because I want to show you external workload automation. Most of the demo will work with Edge 24.8.2 or later. External workload auth will not. And I'm sure there are a couple other things lurking in here that won't work, but most of it will if you decide you want to go with the Edge release for this. If you're going to use Enterprise 2.16.0, which I think you should, you will need to go pick up a free Buoyant ID from enterprise.buoyant.io. It takes like 30 seconds. It's really easy. We promise not to send you spam. The demo, as you will find it in the source, requires both kind and K3D because K3D doesn't support IPv6, and IPv6 is a thing I want to show off here. So some of it uses kind and some of it uses K3D. And man, I really wish... I would love it if K3D would go ahead and pick up v6. Alternately, I would love it if kind would go ahead and integrate a load balancer implementation. One of those two would make me very happy. These are all the tools. I think these are all the tools that I use in the demo. You're not actually going to see step being run because I generated the certs ahead of time, but it's a good thing to have around anyway. All right. So without further ado, then, the top 5 things you need to know about Linkerd 2.16. Number 1, we support gRPC route now, which is kind of like HTTP route, but for gRPC. Number 2, this is a big one. We have metrics and timeouts and retries for both HTTP route and gRPC route, per route metrics, which we did not have prior to Linkerd 2.16. We support IPv6. The astute among you will know that IPv6 is a thing that we talked about earlier in an Edge release, but 2.16 is the first time v6 support shows up in a stable release. So we're going to talk about that a little bit. We have the new policy audit mode so that you can test your policies without breaking your application. Pretty cool. Sounds kind of silly when I put it that way, but it's pretty cool. And finally, as mentioned, we have external workload automation. I'm going to talk about these in the deck in this order. In the demo, I will be doing this in a different order because it makes way more sense in the demo, but that's okay. All right. Oh yeah, and there's bug fixes and things like that in 2.16. I'm actually not really going to talk about those in this particular session because I'm kind of concerned with getting through everything else, but also because mostly the bug fixes are... I guess I'd say kind of long-standing things that showed up in edges along the way. I don't really think any of them are as dramatic as the features. Anything come to your mind on that, Tom?
No, but I'll go ahead and share the release notes for 2.16.
Yeah, absolutely. All right. Number one, gRPC route. But really, we're going to talk about number two, gateway API metrics retries and timeouts as well. Because fundamentally, what we're doing here is talking about gateway API improvements in Linkerd 2.16. So, a little bit of history for those of you who have not been following along on every Service Mesh Academy. Gateway API is a project within Kubernetes SIG networking. It gets started in 2020, primarily focused on the whole north-south traffic thing, the Ingress problem, and specifically the fact that the old Ingress resource had just kind of become this wild west of annotations, no two of which could be shared between any two implementations. The Ingress resource was a pretty rough place to be, really. So Gateway API came along to try to fix some of these problems with Ingress. In 2022, Gateway API started going, hey, maybe we should do this for meshes as well. This is the Gamma initiative, the Gateway API for Mesh Management and Administration initiative. The most horrible, okay, not the most horrible backgronym I've run across recently, but pretty horrible. Full disclosure, I am pretty deeply involved with Gateway API, and I am in fact a co-lead of the Gamma initiative. So if you have complaints about them, bring them to me. I would be very interested in hearing about that. Or, positive feedback too. That would be good, but let's face it, that it's going to be more complaints than positive feedback. Linkerd started to use Gateway API back in 2.12. And kind of the goal of Linkerd is to use Gateway API as our general mechanism for talking about classes of HTTP traffic, which includes gRPC. Excuse me. And, so we want to be able to use it for traffic shaping, for retries, for timeouts, for auth policy, for dynamic request routing, all this other stuff. And we did that sort of, one step at a time as we came in. Back in 2.12, we started with the HTTP route resource. Our initial support, you could use it for routing. You could also use it for things like traffic splitting and canaries and fancier things like that, which we broadly describe as dynamic request routing. You could also use it for authorization. You could not use it for per route metrics or for timeouts or for retries. And that was obviously a problem. It's also worth noting, it's possible to use HTTP route for gRPC. It's unpleasant. It doesn't work all that well, both because the way you have to construct the route is kind of ugly and because it doesn't understand things like gRPC statuses. But, you could do that. So gRPC route was always kind of waiting in the wings there. In general, also, every release between 2.12 and 2.15 inclusive, you could not use HTTP route and service profile together in any particular meaningful way. This was a huge sticking point because there were things that service profile could do that HTTP route could not do. And as soon as you put a service profile in play, you could not put a route in play, and vice versa. So, which means you can't compose them on top of each other. We've already mentioned things you couldn't do. 2.16 is where we start fixing this. Yay! So, first off, we have support for gRPC route now. With basically on par with what you can do with HTTP route, only now you can do it for gRPC. So here is an HTTP route. Not all that dramatic. This one would take every HTTP request with a path that starts with /listall and do something with it. From a routing perspective, this is not a very interesting HTTP route, but now we have metrics for it, and we'll come to that in a bit. It would be possible to tweak this and say, oh yeah, if you see a post with an exact match for /foo.v1.foo service /listall, then we could use that to catch gRPC, but it's much better to change it to a gRPC route and use the gRPC method match to be able to talk about service and method and things like that. The reason the type is still in there is that you can do things like regular expression matches on the method names and stuff like that. It is also worth noting that, yes, you do have matches.method.method there, which is a weird bit of stuttering, but none of us in Gateway API have been able to come up with anything better. Although we can come up with lots of things that are different, it's not clear that they're actually any better. So we went with this. Metrics, I mentioned just a second ago. Basically, what we do is we add per route metrics for both HTTP route and gRPC route. I should have mentioned in this slide that HTTP route and gRPC route can both have multiple matches, basically multiple rules within a single route. We are adding per route metrics, not per rule metrics at this point, which is an important thing to bear in mind. In this demo, you will see places where I have a lot of individual routes which have only one rule in them for this reason. And we are very interested in hearing feedback as to whether that's good, bad, or indifferent for y'all's use cases. Okay, timeouts and retries. You can do timeouts and retries, and you can do them for HTTP route and for gRPC route. We do this with annotations. The reason we do this with annotations is that timeouts and retries are not yet standardized in Gateway API. Timeouts, there is a form of timeouts that's present in HTTP route. It's not yet there in gRPC route at all. Neither of them have retries at all. There's an experimental retry thing that we're working on for HTTP route for Gateway API 1.3, 2, I don't remember. The next thing for Gateway API. But these are both, everything I was just talking about there, almost all of that is experimental. So we decided we'd just do it with annotations. It makes the implementation, it basically lets us focus on the implementation without having to think too hard about exactly conforming to the semantics of Gateway API. Once Gateway API standardizes this stuff, it makes it easy for us to go back and revisit. So expect to see this pattern, I think, fairly often in the future at places where we need to develop in advance of the standard. One fun fact is that service profiles have budgeted retries, and annotation-based retries for HTTP route and gRPC route do at present counted retries. Budgeted retries meaning that you can keep retrying until you hit 20% of your traffic or whatever. Counted retries meaning you can retry, but only up to 2 or 3 times or whatever you set the limit at. This makes Linkerd the only major mesh to support both of those things at the same time. Yay! I'm actually hoping that we add budgeted retries back into the annotation-based stuff too. I already mentioned that you can apply timeouts and retries to HTTP route and to gRPC route. You can also apply them to services. And the reason, if you apply one to a service, then no matter how traffic gets to that service, the retry or timeout applies, which gives you a sort of hierarchical way of approaching this stuff, which is pretty nice. Anything you want to add so far, Tom?
No, I think it's great. And then the annotations, again, when you're managing a big environment, it's not something you have to go out and clean up immediately. You can take your time and take those things out once we shift, if we shift, right? As the direction shifts with Gateway API.
Yep. Another nice thing about annotations. Another thing, by the way, that's kind of fun about the annotations that we're using for timeouts and retries is that one of the complaints that you hear a lot about annotations is that they're unstructured and, meaning they're just, a string to string map. You can throw anything you want to in there. But if you try to use the Linkerd annotations incorrectly, you will find that the validating webhook we have in place validates those annotations as well, which is really, really nice from the perspective of a user. So that was a fun thing to find out. All right, IPv6. We did an entire Service Mesh Academy on this pretty recently. That's the URL, IPv6 with Linkerd, future-proofing your network. If you are particularly interested in V6, I would encourage you to check this out. The whirlwind tour for V6's history is this thing that we call the internet. Is a collection of cooperating protocols that are ultimately rooted in one called the Internet Protocol, IP. which was standardized as IP version 4 in 1981, even before I got into this. That's the one with the 32-bit addresses and dotted decimals and all the stuff that we're all familiar with, because it's the one that's by far in the widest use now. It has the minor difficulty that we've run out of addresses in IPv4. Asia Pacific ran out in 2011. The rest of the world ran out by 2019. Nobody has large blocks of v4 addresses available these days at all. And we kind of dodged this by creating RFC 1918, which carves out some of the address space and explicitly says you can't globally route these. These are for use locally within your site. And there's an implicit assumption that NAT will just make everything work and solve all the problems. This is where Tom gets to dive in and mention carrier grade NAT, and I just try to avoid vomiting and move away from that.
I'm going to avoid that.
Man. One entertaining thing here. Oh, my name is covering this up. Great. Anyway, Kubernetes pod and service siders are pretty much always RFC 1918 addresses. So if you deal with Kubernetes, you have dealt with RFC 1918. You were going to say, Tom?
I was going to say, I've been working with IP6 for, well, since 2011. I saw that number, and people are still avoiding it.
Mm-hmm. Yeah, because it's really, really different.
Yeah.
IPv6, the real main goal of v6 was to tackle that whole address space problem. I would also like to point out RFC 8200 is the most recent revision of the v6 protocol. That's as of 2017. It was actually first proposed, I want to say back in I think it was 1998, something like that, nearly 30 years ago.
Yep.
Maybe 1996. Yeah, 96, I think. It's, 28-year-old cutting edge technology, I think is the way Alejandro put it.
When everybody started coming onto the World Wide Web, right?
Yeah.
They realized this isn't going to work.
Yeah. And the thing that's shocking about v6, like Tom was saying, is that it's really old. It solves a ridiculous number of problems, and people are still dragging their feet on it because of the massive inertia that v4 has. v6 goes from 32-bit addresses to 128-bit addresses. So you could fit the smallest block you're supposed to give out is a /64. And in a 64, you can fit 4 billion copies of the entire v4 internet. So you do not have to worry about address spaces running out in v6.
Not in your lifetime.
Probably not ever, really. But they're written as groups of 4 hex digits separated by colons. But in places where you have leading zeros, you get to omit them in those groups. And any single run of 0 groups you can replace with : : So these bottom 2 are the way these addresses would actually be written in practice with IPv6. Just for the fun of it, the one that starts with FC00 is a local address, link local address in IPv6, which is sort of vaguely a little bit kind of like RFC 1918. It's only supposed to be a thing that happens on your, within your site. And you might see that specific address in a kind cluster, for example. The bottom one is one of the globally routable addresses for www.google.com. Or was when I did this slide. May have changed by now. Who knows? Yeah, I really should turn my name off if I can figure out how. There's also a new DNS resource that goes along with this, the quad A instead of the A record. One other point that's good to know about v6 is that if you are writing a URL with an IP address in it and you're using a v6 address, you must write the v6 address in square braces, because otherwise the colon confuses the address parser and it thinks you're talking about ports, and it doesn't work very well. If you do need a port, you stick it on the end as usual outside the square braces. Okay. Worth noting, there are 3 kinds of internet connected hosts in the world at this point. There are ones that do IPv4 only. There are hosts that do IPv6 only. And then there's the so-called dual stack host, where you support both IPv4 and IPv6. If you go and dive in to if you go head down the rabbit hole on this one, you will find that there are also lots and lots of different ways you can do dual stack, and everything gets ridiculously complex in some ways. But the biggest thing to note about the dual stack world, however you do it, is that in the dual stack world, if you have something with a v6 address and also a v4 address, the v6 address is the one that everything will prefer to use, because that's the way v6 is defined.
Yep. And there's the hosts that are going to be IPv6, but just don't know it yet.
Yeah, exactly. Modern applications or application languages like Go and Rust and Python, like things that aren't C basically, and all the modern OSs just work in this world. Kubernetes supports v6 and dual stack as of 1.23. Linkerd stable also supports it as of 2.16, or I don't remember which edge it is, but there's an edge release too. A big challenge with demoing v6 in Linkerd is that it's almost completely invisible. So it's really, really hard to demo. You'll see that. The v6 demo is going to be really short, but it basically just works in Linkerd, which is really nice. The one gotcha you need to remember for v6 is if you're doing network authentications and you're on a dual stack node, you will need to include both the v4 and v6 CIDRs to make sure your network authentication will work. Not you understand that there would be any personal experience associated with that point.
Yeah, the other thing to remember is that you should always make sure that your cloud provider supports IP6 in the environment you're going to run it in. There's still some stacks that don't do it. So
yeah, v6 is
be sure.
v6 is way more challenging to run in Kubernetes than I would like it to be. We mentioned this a little bit earlier. So K3D is really simple to run locally, right? It doesn't support IPv6. K3S does, but not K3D. I'm not sure what's up with that. I need to go do some digging on that, but it just doesn't do it yet. Kind supports v6 and dual stack beautifully, but Kind doesn't come with a built-in load balancer implementation. So if you want to run Kind, then you also need to run MetalLB or something like that. So you can have services of type load balancer, so you don't have to rely on kube port forward for everything. And so both of these introduce this really weird friction. Like Tom was mentioning, some cluster providers, I think all the major ones support it at least, but they may have weird restrictions on where you can use it, or, oh, no, you're using this kind of an old node. It can't do that,
Yeah,
So,
and again, operating system, same thing. So if you're going deep enough in the stack before you decide you're going to implement it, just dig down to the bottom and make sure that all your parts are going to support it, right? Whether it's in the cloud or it's going to be on-prem or on bare metal or VMs, your hypervisor, everything supports it the way you want it to work.
Yep. In the desktop world, it's easier. Just don't run some ancient desktop OS and you're okay.
Yep.
But yeah, it's a little fascinating beyond that. All right, let's talk a bit about policy audit mode. So prior to Linkerd 2.16, if you wanted to make changes to your authorization policy, you would test those changes by applying those changes. And this had the undeniable benefit that it was guaranteed to accurately reflect exactly what your policy was going to do. And it was also guaranteed to infuriate everybody when you broke your application by making changes that didn't quite work, which all of us did. Policy is the most complex part of Linkerd from the perspective of the people who are trying to set up and operate a Linkerd network. It just is. Policy is hard, mostly because Linkerd tries really hard to be opinionated about how you should do things for most tasks, but we don't get to do that for policy. Policy has to be entirely up to you. So everyone, and I do mean everyone, gets policy wrong when they start changing things, and they will usually get it wrong multiple times. And I am absolutely including people like me and probably Tom and everybody else in Buoyant in that everyone. Policy is tricky. So in Linkerd 2.16, every place you can refer to a policy like all authenticated or deny, you can now also refer to audit. So for example, you could set the default inbound policy on a namespace by annotating it with config.linkerd.io/default inbound policy audit. instead of deny or authenticated or whatever. We've also added a new field to the server definition, access policy, which lets you say in a service or in a server, excuse me, this is how you set a server to audit. It also, incidentally, would let you set it to anything else. So this is a general way to override that default deny stance of a server. If you do not specify an access policy, then it defaults to deny for backward compatibility with pre-2.16 servers. Audit is kind of like deny, except that instead of actually denying the connection, it just logs to say that it would deny the connection. So in the Linkerd proxy logs, by which I mean the Linkerd proxy container in an injected pod, right? You will see new info level logs that will include the magic tag auth.name equals audit, so you can find them. Mm-hmm. And you'll also see metrics, inbound HTTP auth allow total or inbound gRPC auth allow total, and they will have the label auth underscore name equals audit. I'm not going to lie, I really do wish these names were the same, but
yep.
Oh well. Yeah. Also, as of 2.16, the Buoyant Enterprise for Linkerd command Linkerd policy generate will default to including access policy audit in the servers that it generates. If you really, really don't want that, you can use the -- disable audit flag on Linkerd policy generate, and then it will just leave it out, and you'll get servers that deny rather than audit. Okay.
Yeah, audit has been a thing that customers have been asking for, because customers with large environments with lots of security policy would find themselves stuck in between when they would apply new policies, where some workloads had the new policy, some didn't, and some of them stopped accepting traffic. So what you can do if you're rolling it out, you roll it out as audit, and then you can go, and once you know it's doing what you want it to, you can go ahead and set it to deny. And that way you no longer have to worry about getting stuck in between.
I think people have been asking for this for at least as long as I've been at Buoyant.
Yeah.
Which, it's pretty cool, actually. Policy is hard, and it's hard, it's complex. It's really, really nice to have a way to just kind of go, okay, let me start with this without risking your entire application the whole way through, right?
Yep. And yeah, and you can get results, right? And you can see what those results are, and you know what it's going to do. So it's, like a dry run, basically. Yeah. But it also helps in that transition period when you first apply things.
Yeah. And also, let's not forget another thing is that many times I've seen people use tools like this. They turn it on, they start getting logs, and the first thing they do is go, this is very weird. Why is that thing trying to talk to me? And so they'll figure out that something about their application that they didn't actually understand before.
Yep. We like to call that observability fever. It's like when people first mesh and start looking or start doing something new, and all of a sudden something new pops up. We have to say, it's okay. You're just seeing
it's cool
for the first time.
Yep. All right. Finally, let's talk about external workload automation. We did another SMA where we talked about this. Linkerd outside of Kubernetes, the easy way. We also did one on mesh expansion with Linkerd, I think was the title. That's how you do it the hard way. So looking at both, I meant to put the URL for that one up here too. But looking at both of those can be useful. So the whole point of external workloads or mesh expansion is you want to bring your mesh outside your cluster. So it looks like this, where you've got your cluster and you've got some workloads. In our case, you've got Linux boxes, and the mesh extends all the way through that whole thing. There are some real benefits to this one. You can go and deal with legacy workloads that are not ported over to Kubernetes yet, or might be very difficult to port to Kubernetes. You also get access to really small devices. The Linkerd proxy is perfectly happy running on a Raspberry Pi 4. I honestly think we could get it running on some of the Pi Zeros, but I ran into linking issues the last time I tried that. Didn't run into capacity issues. I ran into linking issues. Thank you, Linux. But you have that opens a lot of doors to be able to bring, instrumentation, factory automation, lots of things like that suddenly become possible to use in a highly secure and observable way because you have a service mesh there.
Yeah, I mean, like say you've got a retail environment and you've got handheld devices, or you've got
Yeah.
an assembly line and you've got, touchscreen interactive devices or whatever, but you've got a Kubernetes cluster that's managing all this stuff. This just allows you, or you've got legacy workloads, like you said, that you just can't eliminate, or you've got an appliance from a vendor that has to be part of it.
Yeah.
This is stuff you can start looking at bringing into your mesh.
Yep. And the implementation is simple. All you have to do is run the Linkerd proxy with some custom IP table stuff right next to your workload. Yeah, simple. We'll talk about that in a minute. It does bring with it some interesting challenges, like you have to figure out how you're going to manage trust across all of these things in Linkerd land. That means you have to worry about how you manage certificates across all this stuff. There are some networking issues around IP routing and DNS, and at the moment we assume you're doing this on Linux. So just something to bear in mind. Now, that phrase, run the Linkerd proxy, is doing an awful lot of work. When I mentioned, oh yeah, just run that. Under the hood, it is a very complex process. You get to see all the dirty laundry in the link that Tom just put up about mesh expansion the hard way. Basically what we do though is we run Spiffy we actually run a Spire agent and server at the moment for identity management to use Spiffy. We set up the IP routing table. We connect back from the external thing. We connect back into the mesh to get policy and other routing information and such. Somebody needs to set up an external workload resource for each instance of an external workload so that the rest of the mesh knows where to find it. And then you set up services that are linked to external workload resources. Oh yes, and we also require that you have seamless IP routability through all this. Buoyant Enterprise for Linkerd makes all of this dramatically easier by throwing in an auto registration controller that manages external workloads for you. So the way it goes with this is, rather than having to manage each of the external workload resources yourself, you create an external group resource. You install a packaged piece of Linux software on your edge device that bundles up all of the annoyances with the IP routing table and how to talk to the control plane and things like that. The auto registration controller then fields connections coming back in from your external workloads, figures out which external group they belong to, and then it manages the external workload resources for you. It is so much easier than doing it the hard way. It's kind of not even funny. The end result here is that you end up with external group and external workload kind of being parallel to deployment and pod, where you create the group, you let the controller manage the lower level stuff for you, the same way you can create a deployment and let the deployment controller manage all the pods and such for you. If you really want to, you can still manage external workloads directly, but it's really very much easier not to have to do that. All right. Anything else you wanted to add before we get over to the demo, Tom?
I think you covered it.
All right. That always makes me nervous, but let's see.
We're about to find out, right?
Yeah. Okay. So first things first, we're going to look at IPv6 support in Linkerd 2.16. There's not a lot to show here. I can go through and I can get the services, and you will note, hey, look, they have IPv6 cluster IPs. Yay! And you'll also note that my Faces GUI is deliberately dual stack. We've got the v4 address and a v6 address for its external IP. If I flip over to a browser, it's working. If you look carefully up in the browser, you'll see that I'm talking to the v4 address here rather than the v6 address, which is kind of interesting because it means that it's a v4 connection into the face workload, and then everything behind that is v6. And it, again, just works. And we know it's v6 behind that because nothing else behind that has a v4 address. In fact, even more interestingly, if I flip back here, the face workload itself doesn't have a v4 address. So what's really going on here is that the face, the GUI that we were just looking at is talking to faces GUI, which is then turning around and talking to v6 even immediately right there. So fine print. This is running in a kind cluster because, as we mentioned, K3D doesn't support v6 yet. We also mentioned this kind doesn't have native load balancer, so I'm using metal LB and all this stuff underneath, and I'm using the v4 address in the browser so I can show off the fact that, hey, it just kind of works. Linkerd knows how to follow IP address family transitions. I am also not going to show you how the cluster is set up because that would take a while, and I don't think we have a while. So for all the gory details, there's a script in the workshop repo here called setup.sh that will show you how exactly it's done. Or you can go back and look at the IPv6 with Linkerd SMA that we did earlier. But that's kind of it for demoing v6. Like I said, there's not a lot we can really show here. Just, oh, look, it's v6. Isn't that great? All right. I mentioned earlier that I was going to demo things in a different order than what I started off talking to them. I'm going to start actually with external workload automation, for which we are going to head back to the IPv4 world. Dual stack external workloads are coming soon, I believe, but they're not part of 2.16.0. So we're going to have a K3D cluster, v4 only, running our Linkerd control plane, and then we're going to go and add some VMs around it, which we will do as Docker containers that are connected to the same Docker network as our K3D cluster. So first off, we'll get the K3D cluster running. This is always the part that I love during demos, where I look at the clock and go, okay, I guess we get to find out how much slower Restream is making my machine. Okay. So once this is done, now we have a running cluster, we can next install Linkerd. And I'm going to make sure here that I have Linkerd Enterprise 2.16.0. As you can see there, I've already downloaded that, so it's the one I have. I can run Linkerd version to make sure that I am in fact doing all this with 2.16.0. Next up, we need to install the CRDs. This threw me for a loop the first time I tried it, because the first time I tried it, I forgot that set manage external workloads equals true. And if you forget that, there is no external group CRD installed, and your life gets very confusing very quickly. I can tell you that one from personal experience. Don't make that mistake. After we get the CRDs installed, and you can see that, yes, here's our here's our external group. It got created. That's good. I'm going to go ahead and install Linkerd. This you don't actually need in the v4 world. I forgot that I had that there. Funny. We're going to go ahead and get that going. I'm doing this explicitly specifying all the certificates that I want in the trust chain, because I need to use those certificates to authenticate my external workloads. I did not show creating the certificates because I did it ahead of time, but it's in there as well. All right. Now we run Linkerd check to make sure everything is happy. This is the other point where there are a couple of points in this demo, actually, where things take just long enough to be really concerned that they're not gonna work.
Just have to have faith.
Yep, pretty much.
A lot of coffee.
All right, so now we have Linkerd running. Let's go ahead. We're going to start the faces demo running in here. We'll create the namespace. We'll annotate the namespace so that the things in it will be injected. And then we're going to install the faces demo itself. For right now, we're going to make the faces GUI service its own load balancer so that I don't need to go and install an Ingress controller right at this particular moment. We also are doing some other things, like we're setting it up right now so that things don't fail. And we're installing a color 2 service so that we can flip back and forth if we want. I actually think that's also a holdover from an earlier rev of this demo. Let's go ahead and get that running, and we'll make sure that faces is running. There we go. We can look at our pods. We see, oh yeah, look, there's 2 out of 2, we can see that they're injected. And if I get my faces service, we can also see here is the IPv4 only external IP address of my service. And if I flip over to a browser and then I change my browser, I can see that I still have a running faces here on my K3D cluster. Yay.
Nice.
This is also not very interesting because this is just running our plain old Kubernetes workload. So we will start by throwing away some of those things. And if we flip over now, we will see endless cursing faces on gray backgrounds because the smiley workload and the color workload are no longer running. All right. What we're going to do now is start smiley and color running outside the cluster. I'm going to go through this bit fairly quickly. If you really want to go down the rabbit hole, you can go back to the SMAs that really focus on this one. But high level stuff. External workload has to be on a machine with direct IP access to the pod and service IP ranges of the cluster. The external workload also needs to have access to the Kubernetes DNS so that if a workload needs to talk to some workload that's in the cluster, it can use a DNS name and resolve. And also it can use a DNS name to refer to the control plane itself. These are both important. The external workload needs a SPIFFE identity so that the Linkerd proxy knows that it's okay to talk to it. Our external workload needs to run the Linkerd proxy next to it, just like we do in Kubernetes. And we need an external group resource in the cluster referring to our external workload so that everything can get all linked up nicely together. So we will start with routing. We don't actually have to do anything for routing in this world, which is like in the sense of, I should phrase that differently. Everything that we need to do for raw IP routing is baked into the things we're going to run for the external workload. We do need the IP address of a node within our cluster so that we can route traffic to it from our external workloads. That's probably unsurprisingly the same IP address as the load balancer service we just saw. We also need to know the pod CIDR range and the service CIDR range. We can read the pod CIDR off the cluster. For some weird reason, you can't read the service CIDR off the cluster directly, but we happen to know that it's 10.43.0.0/16. So we need all of that to hand off to our external workload so that it can properly run the IP route add command to say, hey, any traffic to the pod CIDR or the service CIDR, please route that over to the node IP. All right. DNS. We're going to tackle DNS in kind of a weird way. We're going to edit the kubedns service so that instead of being a cluster IP, it is a node port on UDP port 30,000. And then we're going to run DNS mask in a separate Docker container to take requests and then funnel them through to port 30,000 in the cluster. The reason that we have to go through these kinds of gyrations is that it's actually pretty difficult to make DNS client libraries use non-standard ports. And it's also pretty difficult to use port 53 on the node because the Linux DNS machinery really wants to use that instead. So we're going to do it this way. This is probably not ideal, but it does give us a fair amount of control over what exactly we're going to expose, which is nice. And so it's probably not a terrible way to do it. So first things first, we will edit this to be a node port. And I'll come up here and explicitly say this needs to be node port 30,000. So we do that. If I now read that service back, we can see that, oh, look, it's now listening on port 30,000 UDP. Great. And we're going to fire up DNS mask in a container using somebody else's DNS mask image, which I always really like. It's pretty simple. It literally just says, okay, you need the DNS host. And it runs it injecting this single server record that says anything that ends on service.cluster.local goes to our DNS port, our DNS host on port 30,000. And then it just sits there and sleeps for an hour over and over and over again. The particular way that we're going to run this is a little weird. The DNS mask image wants to run a shell script the DNS mask image, if you leave it alone, starts DNS mask in a much more complicated way. So instead, I'm going to volume mount our DNS forwarder shell script and then override the entry point to run the DNS forwarder shell script, which is probably best described as a brutal hack, but it works really well. Once that's done, now our DNS mask container will have an IP address. We can read back that IP address, and then we can tell our external workloads, hey, this is where you go for DNS, because that will permit them to go to port 53 on that IP address and get access to Kubernetes DNS in the way that we have set up. Next up, so what we're about to do here is a horrible idea. Don't do this in the real world. It's just wrong. What we're going to do is run a Spire agent. That's not the horrible idea. The Linkerd proxy knows how to talk to a Spire agent to get a spiffy identity. The horrible part of this is that we're also going to run a Spire server on all of our nodes, all of our external workloads, right next to the Spire agent, and that is a horrible idea. The right way to do this is to run the Spire server on some single place where you have control over all your certificates and you've properly secured this. We're doing it this way because it's so much simpler as a demo. That's actually a good one for a future SMA, Tom, is we should do external workloads with real Spire,
Yeah, again, we talk about taking all these little sandboxes we have and merging them into one mega sandbox that has all the things. So maybe that's something we could build someday that people could just download and play with.
It is a little tricky because one of the challenges with Spire is that Spire gets into organizational policy, and that makes this sort of thing difficult. But we could certainly do something where we say, oh yeah, here's a basic set of policies or something. This is our Bootstrap Spire script. It looks long and complicated, but it's really not. We must have a spiffy ID environment variable set so that we know in the external workload what spiffy identity we're trying to fetch. We have to have the trust anchors certificate and private key. We then run the Spire server. We sit there in a loop until the Spire server gives us a magic token that the agent can use to authenticate itself to the server. Then we use the magic token to create our spiffy ID. This selector business is saying, hey, if somebody shows up on a Unix domain socket and presents the correct Unix ID credentials, and we're going to use the user ID of the proxy harness user, which is set up by the stuff we're going to install, by the Linux package that we're going to install for all of the harness stuff. Then if they present that UID to the Spire agent, then the Spire agent will be willing to talk to them and give them the spiffy ID we've just created. And then we just sit there and wait for the Spire agent to be ready so that we know that everything is okay. And all of that happens before our main workload gets started. Sorry, I'm staring at this because I just made the horrible mistake of getting sucked into reading what I was writing instead of just talking about it. Oh yeah, what were you saying about needing,
the one
what
thing
were you
that
saying about needing more coffee, Tom?
No, I do have a sip. At a high level, the one thing that you have, to think about is that these external workloads are kind of like a pod, right? Yeah. And then when you go back and when I used to teach and intro Kubernetes stuff, you explained that a pod is kind of like a host, right? With the local host network and shared, right? Because in Linux, it's all just a bunch of pooled shared resources and everything is put into one little bucket and it thinks it's the world, but it's not really the world. It's just its own world. And this is the same thing. We're abstracting it backwards. We're saying, look, we're going to treat this as a pod, sort of, even though it's an entirely, hydrated system. So,
and the important thing with treating it as a pod is that we basically have to replace the things that the Linkerd proxy wants around it from the pod so that the Linkerd proxy runs nicely. In doing this the hard way, there's an enormous amount of stuff that comes in at this point, but doing it the easy way, what we do is we install this package that belongs to the auto registration controller, and then it does all of this stuff. And the way that ends up looking is we have this image, the demo Bell external base Docker image, that mostly just runs this one bootstrap bell script, which goes through and does all the things here. After screaming about how it's not production ready software, it uses RPM to install the harness package itself. That package is baked into the Docker image here. It makes sure that we have the workload name and workload namespace set. These are critical and magic because they are the thing that will permit the auto registration controller to figure out what external group your external workload belongs to. We then set up, this is the spiffy ID we want. It's also based on the workload name. And then we run that bootstrap Spire script that I was talking about. We manage all the routing that I mentioned, routing the pod cider and the service cider via the node IP. We set some things for the harness, which is basically saying, hey, when you run the proxy, make sure that you're going to be looking at the external workload group named this in this namespace. We set some stuff for how to find the control plane, really, and which identity we're going to be using. And then finally, we start the proxy running, and then we start the workload. This bit down here, workload start, is up to you. If you're building on top of this Docker image, you're going to need to provide workload start. For our purposes, there is a faces bell external workload 1.4.1 image out there, which is literally demo bell external workload with the faces workload binary copied into /workload/start. So with all of that, we can finally start running these things. We're going to do this first. We're going to create an external workload for our external group. We're going to create an external group for the Smiley workload. Its name is Smiley. It is in the faces namespace. We get to define, like a readiness probe here so that the auto registration controller can figure out when our external workload is ready before it starts routing traffic to it. The rest of this should look remarkably like a deployment, right? We get to go through and talk about a template, in this case for our external workloads, but we get to put on labels to match them up to a service. We've already created the Smiley service. We get to tell it about ports. So let's apply that. That's not going to do anything so far because we don't have any external workloads registering with it yet. So our next thing is we're going to start actually running one of these external workloads. This is a very, very long command. It's not that bad. Remove the container when it's dead. Detach it, aka run it in the background. We need the netadmin capability to mess with IP routing. We're going to connect it to the same network that our K3D cluster is on. We're going to tell it to use our DNS mask container for its DNS. We're going to tell it that the name of the container is Smiley1. We're going to set the host name to something slightly different just because that way the faces GUI is happier with it. We're going to mount the Spire certificates in to this thing. You remember the Bootstrap Spire script needed certificates that are in that directory. So we're going to volume mount those in. Workload name and workload namespace are critical. We want this to connect to the Smiley external group in the faces namespace. Much of the rest of this is all about things that the faces workload wants. The node name is actually some debugging stuff. And then we're going to run faces bell external workload 1.4.1. When we start that running, let's also, so what we're watching here is we're hunting for external workloads in the faces namespace, and we're also hunting for endpoints endpoints for the Smiley service. And poof. You notice there that the external workload showed up before the endpoint did. The external workload shows up pretty much as soon as our external workload registers itself with the controller, but the endpoint doesn't get created until the probe succeeds. So we actually have to wait for the thing to be running.
So the
We're gonna do,
interesting point
yeah.
is, right, we need to give it netadmin because we're going to do the same things that we would do in a pod on a Kubernetes cluster. We're going to modify IP tables, and then we are going to inject a proxy or start a proxy, right?
Yep.
And
And if you have done, if you've gone through the SMA on what really happens at startup, you'll also realize that the Linkerd proxy, either we have to have netadmin for the Linkerd proxy in Kubernetes, or we have to use a CNI plugin.
mm-hmm.
So at this point, with the Smiley workload running outside the cluster but reachable from inside the cluster, we get grinning faces on gray background. So we're going to do exactly the same thing for the color workload so that we can get our blue backgrounds instead of gray backgrounds. Everything about this is the same except that, the name has changed from Smiley to color. We'll apply that. We'll do the same Docker run thing. All right, I'm not going to wait all that long this time. Again, it's exactly the same thing, except that all of the instances of Smiley changed to color. And when we run that, this is now watching for endpoints for the color service. There's our external workload.
And
there's our endpoint.
Go.
And there's our shiny, nice blue backgrounds.
Beautiful.
Yeah. All right. So now at this point, we have the face workload running in the cluster with the faces GUI, and we have the Smiley workload and the color workload running outside the cluster, but looking like they're running inside the cluster because they're reachable from inside the cluster. It's also worth noting that external workloads, we were looking for endpoints. We also have endpoint slices defined for these things. And you can see that there is a normal endpoint slice in here, which shows nothing at all. And then we've got the ones that are named Linkerd external something or other. The normal looking ones are being created by the normal endpoint slices controller, which doesn't know anything about external workloads. The Linkerd external one is being created by Linkerd's endpoint slices controller, which does understand external workloads. So that's why they're the ones that show up with the correct IP addresses.
So do the ones that are created by the endpoint slice controller just point to the other ones?
No, they actually point nowhere at all.
Oh.
They're just sitting there being useless.
They just need them as placeholders?
Well, it's mostly because until I think it's KEP 4770 lands, there's no way to tell Kubernetes, hey, endpoint slice controller, just ignore this.
Okay, cool.
Yeah. So, we end up with these empty endpoint slices that do neither any harm nor any good and whatever.
Can be ignored.
Yeah. So what else can we do with this? Once again, endpoint external groups and external workloads are kind of like deployments and pods and such. And one of the interesting things here is we can create additional external workloads and then do other funky things with them. So in this case, I'm going to create a new service called Smiley2. Oops, where's my mouse? There we go. I'm going to create a new service called Smiley2 that is looking for a selector of service Smiley2. And then I'm going to create an external workload named Smiley2 that looks a lot like the Smiley one, but has a different name. Mm-hmm. I will apply that, which is going to do absolutely nothing right now. And then I'm going to run a Smiley2 workload. The name is Smiley2. The host name has Smiley2 in it. The workload name has Smiley2 in it. That is critical. And we're going to give it hard-eyed smileys, but we're also going to have it fail 25% of the time. So if I turn that on, then we would expect to see that we get some, external workload and some endpoints show up. There's our external workload. There's the endpoints. And nothing looks different because the only thing that the face workload is talking to is Smiley. But we can change that with an HTTP route. So what I'm going to do here is I'm creating one called Smiley Center, where if the path starts with /center, it's going to be the usual Smiley service. The reason that this is going to go to the Smiley service is we don't have a backend ref here. If you have no backend refs, the target defaults to the same as the parent ref. And then we're going to do another one called Smiley Edge that looks for edge, but it has a backend ref of Smiley 2. This is a slightly new tweaked version of the phases demo where the central 4 cells use the /center path and the other one use the /edge path. So when we do this, we're going to apply this, and wow, that's awesome. I've seen this take like a minute or two for no reason that I've figured out, and this time it just worked beautifully. And so you can see the center cells are just sitting there doing their thing, and the edge cells are now getting hard-eyed smileys and failing sometimes.
25%.
Yeah. We will leave it as an exercise for the reader, how many cells there are on the edge and what 25% of that number is. So the fact that those are external workloads doesn't actually change what Linkerd can do when it works with them. And also we have metrics for these things now. So significant limitation here in the metrics world is that Linkerd Viz does not know how to display these shiny new metrics that the Linkerd core is publishing. There is some very cool stuff coming down the pike for this, hopefully in a soon future release. I've gotten to see it. It's very cool. But for the moment, we're kind of stuck using the Linkerd diagnostics proxy metrics command. Or if you want to go back to the metrics and dashboards and charts, oh my, SMA, we go down the rabbit hole of talking about how to use Prometheus itself and Prom tool to query all this stuff and set up Grafana dashboards and all that cool stuff. But for right now, we're just going to stick with proxy metrics and ugly shell hacks. Proxy metrics needs a pod name to work with. So we've just fetched the pod name of the face service pod. And if we run that, we will get a truly massive slew of things. So lots more digging in the metrics and charts and dashboards, SMA, metrics and dashboards and charts, oh my, SMA. For right now, we're just going to cut to the chase and say, hey, there's this metric called outbound HTTP route backend response statuses total that gives us a breakdown per backend ref of what happened to requests made, in this case, from a particular pod. So we're going to look at that. And even that is a pretty fair amount. Let me pick on one of these for a second. So that's a single metric. And we can see some interesting things in there, but let me break this down a little bit more. What we're doing here is running proxy metrics. We're going to grep for our metric name. Then we're going to grab the first 2, and then we're going to turn every comma into a new line to make it easier to read. And if we do that, okay, so here's a metric where we can see things like we get to see a status here. We get to see the namespace of the backend and what it was. And we also get to see things going through here. We don't really see this with just the top 2. Let me scroll back a second here. Here we go. This one's slightly better. Oh, naturally, it's the third one, of course. If we look carefully in here, you'll see this business of route name equals smiley edge. That was a little fascinating. Oh, I see what happened. Since the route name is present in that metric, then that gives us a way to look at specifically the metrics just for face trying to talk to the route that we just set up to route over to Smiley 2, which we know is failing. And if we do that, here I'm looking for, I want only the ones that say route name of Smiley Edge, and I also want only the ones that don't say HTTP status 200. So here I'm only looking for the errors. And if I look at that, then I can go through and see things like, yeah, perfect. We get a 500. There were 378 of these when we last did it. There's a lot of information in here. All of these parent underscore labels are talking about the parent ref that this traffic belongs to. The route underscore things are talking about the route itself. Hence, route name, route namespace, route kind. And then we get some backend stuff to tell us which of the backends for that route it went to. If we do that particular thing there twice and sleep for 10 seconds in between, then we'll get a sense of just how quickly these things are failing. So 450, 10 seconds later, 463, 463 minus 450 is 13 divided by 10 is 1.3 a second. Okay. This seems really primitive, but this is actually the way Linkerd Viz and Grafana and all those funky tools work when you go under the hood, is they're grabbing these things and doing math. And again, metrics, dashboards, and charts, oh my, we go way down the rabbit hole in that one. Now, if we want to make the cursing faces go away out there on the edge, then the only way to do that in Linkerd 2.15 was to mess with a service profile, which would mean that we would have to get rid of our HTTP route, which would be sad. But in Linkerd 2.16, we can just stick these retry.linkerd.io annotations on there. And now suddenly we have no cursing faces. If we watch long enough, one's going to slip through, but you know, we get way fewer. Another fun thing here is that we have metrics for retries. Again, per route sorts of things. They're under the metrics whose name begins with HTTP, outbound HTTP route retry. And once again, we have the route name buried in there somewhere. Here we go. Here's one with route name equals smiley edge. You'll see some of these say a route name of HTTP. That means that Linkerd doesn't have a specific HTTP route that matches this traffic, so it just kind of synthesizes one called HTTP, so you get the metrics anyway. But in this case, we can look at the route retry stuff for smiley edge, and since even that is a little unwieldy to read, we can take the same information and then use sed again to throw away all this stuff inside the curly braces. Because really, since we're already filtering it by a specific route name, this is kind of all we really need to see. And from that, we can observe that, oh, okay, so we've made a bunch of these things as retries. Most of our retries are working. In this particular case, retry limit exceeded total means how many times have we hit the limit and given up? In our case, 0. Great. If I leave it running for long enough, that number will become non-zero. Route retry overflow total actually only comes into play when you also have circuit breaking involved. So we should see it being 0 here, and we do. Now, let's also do some playing around with timeouts here. You'll notice that some of those cells fade away because things are slow. So we can put in this case, we're going to put in a timeout on the color service itself. And we'll just put in a 300 millisecond timeout on the color service. Remember, however the traffic gets to that service, this timeout will take effect. So when we do that, we should immediately start seeing some pink backgrounds because the color service is slow and it renders as a pink background if it hits the timeout. We can also go through, if we want to, and add a timeout to the smiley edge HTTP route. Same one. And now we see sleeping faces, but we do not see any sleeping faces in the center of the grid because we only added this to the edge HTTP route. So being able to apply these at multiple different levels turns out to be kind of handy. Now, we're going to look a little bit at gRPC route, although we're mostly going to look at gRPC route for metrics rather than routing. I am going to get this going, and Tom, now would be a great time if you have other questions, because there are certain gyrations we want to run through to get Emojivoto up and running here. And I'm picking on Emojivoto because right now, Faces is all HTTP, but I actually have to fix that for KubeCon because we're going to be doing a talk at KubeCon about some of this routing stuff too. Now, limitation of K3D. We can pretty much only have one load balancer thing at a time, which is really annoying. So what I'm going to do here is turn the faces GUI thing that we've been talking to so far back into a cluster IP, and then I'll turn the Emojivoto web service into a load balancer. And then if I look at Emojivoto, now it has taken over 172.17.0.2. And if we head to the browser and reload a time or two, oh, come on. There we go. All right. Browsers suck, man. So there we go. There's the world famous emoji votes. We can come over here. We can vote for some stuff. We can view the leaderboard. And, there we go, right? Okay. So we have a group of gRPC route metrics that look a lot like the HTTP route metrics. In particular, we've got one called outbound gRPC route backend response status is total. And that looks a lot like the one that we were messing with earlier for HTTP. We're going to do that by looking at the web service pod in Emojivoto. And now we can run diagnostics proxy metrics and look for those things. And if we do that, we get nothing. The reason is that where Linkerd can synthesize that sort of default HTTP route, it will not synthesize a default gRPC route because it's a little weird to do that. So instead, we're going to get some gRPC routes going. Here are the ones for the emoji gRPC service. It has things like listing all the emojis and things like find an emoji by its shortcode. And that's all it has. So we can go ahead and apply that. And we've got those two things. There's also the voting service. Emojivoto is a little interesting. It does not have a vote gRPC call that you pass the name of the emoji to. It has a separate gRPC for every single emoji. So if we do this, we see lots and lots and lots of routes. And when we apply it, we get lots and lots and lots of routes. Yeah. But now we should be able to see some metrics. There we go. It's a lot more interesting to split this out by the route. So this is a pretty disgusting looking piece of sed, but we're taking the same output. Then we say substitute, match this pattern, start at the beginning, have anything at all, followed by route name equals and a double quote. Then we're going to start a sed group, which consists of anything that's not a double quote, followed by 0 or more things that are not double quotes. This is the end of the group. Then we need to see a double quote, followed by anything and a space, and then another group that's a sequence of digits, and then the end of the line. And we're going to replace all of this crap with the second group, which is the count at the end of the line, and a space, and then the first group, which is the name of the route. Come to SMA for Linkerd. Learn about sed. Sed is actually a really useful tool, although it's ugly to work with sometimes. If we do that, then we get this sort of thing, right? Where it's all broken out, where we see the count, the number of times that it happened, and then we see the name of the route. We can kind of build a poor man's Linkerd viz top from that by taking exactly the same thing, sorting it in reverse numeric order, and then taking the top 10. And when we do that, we find that the emoji listing and finding services are just getting hammered. And I'm not going to lie, I don't quite know why. That feels like something that'd be likely to get cached, but evidently not. We can also see that there are a lot more votes for the donut emoji, vote donut route, than for anything else. And I considered trying to go and split that out further with sed, and it got really annoying really, really fast. So instead, let's just look at the raw metrics for vote donut route. And when we do that, we find that there's only one of them, and it says gRPC status unknown. gRPC status unknown does not mean I don't know what status this is. It means there was a problem, but I don't know what the problem was. So that ain't great. That seems to imply a problem here with our voting for a donut. And if we check a different one, which is the joy emoji there, nothing is voted for the joy emoji. Crap. All right.
What?
Hang on a second. Blind luck, I guess. Or, not so luck. I'm pretty sure I see votes for the 100% emoji, which I think is 100. Oh, whoops. Yeah, there we go.
There you
Okay.
go.
And it returns a gRPC status of okay, which is what we expect to see when things are working. So what this is telling us is that, oh yeah, there's a problem with voting for a donut. And in fact, if I come over here and I click on vote for my favorite and I click on the donut, it gives me an error. This is a deliberate bug in Emojiboto so that you can find it with observability and then go fix it in the source code. I considered going through and using it to show off, oh, hey, we can do retries or something like that. But it always errors. So there's kind of no point in retrying it. So like I said, we're pretty much just going to show off gRPC metrics here. There are an awful lot of other things that we could do, but we're not going to bother. Yet another plug for metrics, dashboards, and charts, oh my, because there's an enormous amount more stuff that you could do with this. Two really important notes on metrics before we leave. Number one, again, there's some very cool stuff coming in metrics. Stay tuned. Number two, everybody does remember that Smiley and Smiley 2 aren't even running in the cluster, right? This is the really cool thing about the rework that's been happening for metrics and timeouts and retries and all this stuff in Linkerd is that all of the fancy stuff is actually happening in a layer that's independent of actually communicating to stuff, which means that it doesn't care where the endpoints actually are, which makes it dramatically more powerful for multi-cluster and for external workload. And that has been really, really cool. So for example, you can actually do things like circuit breaking for external workloads, and it just works. It's great. All right, finally, this is actually going a little bit longer than I thought, but I think we can make it. We're going to talk a little bit about authorization policy. I'm turning the Emojiboto web service back to being a cluster IP because I'm going to install emissary, and I'm not going to mesh emissary. So what we end up with here is our Ingress controller is just sitting there out on its lonesome, not being part of the mesh. And this is another one that always takes a little bit longer than I would like it to. So anything else come to your mind, Tom?
Nope, just coffee. But yeah, definitely go check out the SMA on metrics. Metrics is one of those things that customers are very, very interested in, and that seems to be increasing. It's really cool now that not just metrics, but other functionality, is going to be functional without you having to have those workloads in that particular cluster. So you're getting a lot more out of workloads that don't live there. And, it's just becoming one big data plane, right? And one big set of metrics, and the possibilities are expanding. And like Flynn said, as we get more feedback, as we get information from the community about what kind of metrics are handy to them, what kind of metrics are painful to compute, like in Grafana, we could really use a native metric. We're adding that stuff. So keep your eyes on that space because metrics are evolving pretty rapidly.
This is where, all right, come on. Let me, I'm doing stuff in another window for, okay, where's my load balancer here? This is really not amusing me. Well, you know what? We might end up calling this one because something is not being polite here. I swear it worked right before this.
Of course it will.
Well, yeah, I mean, that's kind of a given, right? Hang on just a moment. Actually, I should just do this where people can watch me scrambling around anyway. You also get to see how badly I type when it's actually me typing. Well, that worked. That worked. So my web browser is the one that's not being polite here. Really? All right. Let me try something here. Okay, so let me cheat a minute. I know it's not cheating; it's using all available resources or something like that.
That's right. It's being innovative. Oh, there you go.
So what I just did was I switched to an incognito window and then changed the share. So I still don't know what was up with my other window. I'm going to blame the browser at this point because that's what we do. All right. So remember, we did not mesh emissary with this. And if we look at the pods, you can see there's only one container in there. We definitely don't have Linkerd involved. There's no sidecar in here whatsoever. So we're going to lock things down so that only meshed workloads get to talk to things in the faces namespace, which we would normally do by annotating the namespace with a config policy with a default inbound policy like all authenticated. But if we do that, obviously the whole application will crash until we get emissary meshed. So instead, we're going to use the audit policy in place of all authenticated. So we'll do that. As always, you have to restart the workloads after you change the default inbound policy for those workloads. So we do that. If we go back to the browser, hey, it went back to the right window. I'm so happy. Everything is still working. And if we look at the logs for the face workloads proxy, then we will see lots and lots of things with auth name equals audit. And in this case, a client IP of 10.42.0.23. This is saying, hey, look, TLS none, no client hello, because we're not doing TLS because emissary is not meshed. And so we get to see auth name audit from 10.42.0.23. If we check the pod IP for emissary, 10.42.0.23, that is the pod that is making these scary unauthenticated connections. And we can also look at the metrics for these things. We have to go and grab a new copy of the face pod's name because we restarted it, right? And if we run proxy metrics here, looking for inbound HTTP auth allow total and looking for auth name audit, we will see things like this that look remarkably like the last one. Here, we don't really want this port 4191 thing that has to do with control plane and metrics and such, but this is the first one that matches up with what we got. Fascinating thing about this metric, the metric doesn't tell you where it came from. It tells you where it's trying to go, but it doesn't tell you where it's coming from, which I found a little odd. But yeah. Finally, as we mentioned, Bell's policy generator has been updated to use audit mode. So if we run Linkerd policy generate, and then we look at the output stuff, you can see that every server that it writes will have access policy audit because we didn't tell it otherwise, which means that we could go and apply all of this stuff and get a slew of logs that we just generated instead of having to write ourselves, which is nice. Now, I personally also found that the policy generator generated for some of my namespaces, but not other ones. I am still getting to the bottom of that, so I'll update this workshop once I figure out what I did wrong.
Yeah, there's a couple interesting things to remember. Number one, you have to have traffic. And these are the
Yeah,
things we run
which I
in
do.
when working with customers. You got to have traffic. You're not going to see anything. It's the last 10 minutes of what the proxy sees.
Right.
And that, if you want to do a smaller subset, just set up a context and you can use the dash dash context switch. If you want to just capture a particular namespace or traffic from a subset of things, you can just set up a Kubernetes context and run it against that. There is also concurrency. If you have a lot of things, we have a new feature where you can run more than one, and speed up
I
the
think it
process
actually I
generation.
think it actually defaults to 10, but you can set
Does
it
it?
higher if you need to. Yeah.
Yeah, that's one thing customers said is this takes a long time. So we have,
Yeah.
introduce the concurrency option.
Yep. But anyway, there you go. There's our whirlwind tour of the 5 things you need to know about Linkerd 2.16. There is a lot more to Linkerd 2.16 than this, but yeah. Let's go quickly back over here because I did want to mention a few gotchas, only a few. The big one we already talked about. Viz does not yet support Gateway API metrics. There is, I promise you, there's some cool stuff coming along here, so keep an eye out. But for now, it's pretty manual. Related, Linkerd Diagnostics proxy metrics requires a pod. You can't feed it an external workload. This made me very sad. But, this is one of the few areas where you have to think about where your workload lives. And for most of the scenarios I could come up with, a lot of the time you're going to be talking from the workload back to your cluster anyway. And so there is a pod involved and you'll be able to figure it out from one side or the other. And finally, as we've mentioned, running v6 Kubernetes is a lot more annoying than I would really like it to be still so far. Beyond that, I was running Buoyant Enterprise for Linkerd. You should try it yourself. It's pretty cool. Buoyant.io/enterprise Linkerd, or scan the QR code there. We have an updated Service Mesh 101 online course. You should definitely go and check that out as well.
Definitely.
And then let us know what you like or don't about it. I think it's also fair to say that I'm in the middle of the Linkerd in production course, following on for this one, which should be kind of fun. And next time around, October 17th, we're going to be talking about Linkerd and Backstage. That'll be me with Ben Lambert from Spotify, who's one of the Backstage maintainers. That should be pretty cool. You can sign up for that at buoyant.io/SMA. And I think we're pretty much at time. I'm not seeing questions far. So I think we might want to just go ahead and wrap things up for this one.
Definitely. If you're going to be at KubeCon, come look us up.
Absolutely.
We'll be there.
I'll be there.
There are talks. There will be quite a few, right?
I think we have 8 or 9 different talks this time.
Yeah, high acceptance rate this year. We're very lucky.
Yeah, I was very, very pleased with that. You're there as well, right?
Yes, I've got one for load balancing, and I'm going to be co-presenting the weirdest bugs.
That I'm hoping I am not double booked for that one, because that one will be fun.
Yep.
I'm doing co-presenting a Gateway API workshop and talking about. I think both of mine have to do with Gateway API in the main conference this time around, and then
I'm looking forward to load balancing. Has been the one thing I've been here eight months, and that's the first thing I latched onto and worked on some things with William on that. He wrote a blog post, so going to bring that, and we're going to talk about endpoints, topology aware routing, and better ways to route and to load balance with,
which should be cool.
Oh, it's absolutely cool, and customers love it. Right, load balancing not only saves them money and cross-zone traffic, but like for folks who are extremely latency aware, you can start doing things around that and steering traffic in a way that shaves your latency.
Yeah, that's the Hazel feature, which is very, very cool.
Yeah. It's not just for cloud, right? A lot of folks said, "Oh, it's great, you save money in cloud," but I live in Chicago. There's a lot of financial companies here that are extremely latency aware. So this is a way that you could design a topology and then nail it to that topology to reduce your latency. So.
Yep. All right. Well, thanks everybody for tuning in. I think we're going to go ahead and wrap up, and we will talk to y'all on Slack.